So hello, I'm the new robot. um, and forget about car. Web development is important. No, I want to talk about a project that I've been working on for the past 2 years almost. I mention it occasionally, and lately a lot of stuff has. There's been a lot of progress, and I think it's becoming quite interesting. Perhaps even for everyone. I know that our community is pretty full of game developers, and they are not very, how shall I say, they are very skeptical about all of these ideas that come from the web. But I would just mention that one big AAA game just recently was written with MobX and React, and uses kind of the same ideas that are used in Coconut. And I think, well, apparently it can be made to actually run at 60 FPS, which everybody is very concerned about. So yeah, I'm gonna talk about how Coconut kind of compares to that. It's something I started creating at Dockler because we had a huge code base. Well, it's still pretty huge, but it was based more or less on ideas from Java Spring and pure MVC and stuff like that. Pretty big enterprise level stuff, a lot of XML floating around, and it generated some 6 megabytes of JavaScript or something. So that was management was not very happy with that, and there were also a lot of bugs because all of the levels of indirection were kind of hard to follow. So we wanted to have something kind of simpler, and I had heard about unidirectional data flow and functional programming and all this kind of stuff, and I said, okay, this might actually be a good fit. And then we looked into using React, and that was basically impossible back at the time because React is very opinionated about how it handles all the views. It wants to have basically from instantiation to teardown, it wants to do everything. And on the other hand, you have your own framework that also is very opinionated about object lifecycles. There's no way to bring these two together. So hence Coconut was basically created. It's a very layered thing because that's how I like to do things. So one of the important parts of Coconut is the Coconut data library that allows you to basically define objects and properties on them, and it makes sure that all of them are observable somehow. So when you change something, notifications get dispatched and everything, and it's basically what MobX that I mentioned here. It's a pure hex counterpart to that. In most cases, it performs a bit better because of static typing for one, and secondly because it uses it's lazy by default, whereas MobX is eager. So, for example, if you have complex computed properties, like for example the sum of the prices of some list of items that you have, then anytime some of those items change in price, then the price updates. But so long as you don't actually ask for the price, it's never computed. So yeah, it's relatively clever in that regard. Then there's a UI layer which basically knows how to wire up UI components with this observable data. And this then goes into a renderer. Currently there's 2. One is to render through React, for which there are good reasons. And one is, this is actually relatively new. I created a new library which is called Coconut Diffing. There's some 400 lines of code, and that's just a cross-platform differ that's used to basically look at okay, perhaps I should say that before. Views basically work by describing the structure that they want to present next. And anytime a view updates, it produces a new structure with a pure function. And to make this cheap, essentially, like to not have to rebuild the whole UI all the time from scratch, these 2 snapshots are then compared, and only the differences between them are applied to the UI. And this turns out to be relatively fast. Fast enough for games. And so I built such a differ in a completely cross-platform way, and then I made an implementation of that just for HTML. But there's There's also a renderer which just uses React, which has its own diffing, and then you can plug in either Preact, which is a lightweight alternative to React, in fact with somehow the same API, or React DOM, which renders to React, or React Native, which actually, rather than describing HTML structure, describes native UI structure. Then that stuff is sent to the UI thread, and there this stuff is applied. But your whole application runs in JavaScript off of the UI thread, so it doesn't even block if you do crazy stuff. So that's actually quite nice. The React part has been around for a long while, well, a year maybe. Kevin is using this extensively. These are 2 videos that I like to share that he made for me. So this is basically, on the phone. This is the internet. Well, like you can see on Android, but this is basically Coconut with React Native rendering, just some simple to-do list application, and it's native UI with but using hacks and using the simple paradigm of functional UI description. And yeah, well, the other one is in Android, but basically it's not very exciting either way. So yeah, then there's, you can't really see this benchmarks, I guess. So there's many ways to render stuff to HTML. Nothing in Coconut is new. It's just written from bottom to top to bottom with hacks, static typing, and all this kind of stuff. So it actually, I guess some of you guys, well, maybe I can just show, know this. This is kind of the sample UI JavaScript UI framework application where you can you do stuff, and then basically everything is supposed to somehow update, and you want to make it short. And you can filter these to-dos and everything. So for a long time this was used to kind of give you it's a UI hello world of applications basically. What? What's wrong?
Well, my TV is acting up. Just
okay. I didn't see that. So yeah, kind of the hello world of UI applications. And so if you were to compile all of this with Coconut's own HTML renderer, then the whole application comes out at 28K minified. For comparison, React alone is 100K.
Well.
and here in these benchmarks we basically see, so okay, well here you don't see much, but basically at the top here is this is Preact and Coconut for 100 items in the list. So that this is the benchmark that the Preact guy made to show everyone how fast Preact is compared to React. Smaller is better, yeah. This is 500 items, so here you see on Chrome Preact is still a bit faster than Coconut, and then you see with 5,000 items, well, you don't actually see that, but I happen to know Coconut is some, I don't know, let's say 15% faster than Preact, and React would be off the charts, like somewhere here. So like starting at 500 is the last one where I actually put it, and this is just the fastest one. And yeah, depending on browsers, you get different results. So yeah, TV acting up again. But as I said, that was really the old renderer. I redid it again based on this new cross-platform differ that I created. And this is just basically you launch the application and let it fill in 5,000 to-dos, and you wait until it stopped rendering. So you can see the pure hex version is done in 1.3 seconds. The Preact version is done in 3 seconds, and React in 7 or something. And those are the differences in performance. Although, and they all look exactly the same. Like this is, for example, the React version, and it's the same code. So you can just choose this renderer. Like you would choose React, for example, if you want to have all of the React ecosystem. Like a lot of the time, you're not going to be displaying 5,000 to-dos in the beginning of your application. You do something, and then you load more data and everything. And so yeah, for example, how do I open DevTools in this thing?
No,
Any Mac users here?
Command Alt I.
Command
Alt.
Alt is option, I guess.
Yes.
Oh yeah.
Woo!
So basically you can, so there's this React Dev tools where you can actually look at the whole application structure. So we have the base view and then the header and everything. So I mean React has all of this giant ecosystem around which you can just use in this way. And do other things that might be interesting, like I don't know, fill in some items, and then if you're interested, for example, in how and when it re-renders certain things, and you can see, for example, if you click here, then the header, the footer, and the item that's changed have to make an update. And this is, well, I might actually compare this to something. For some weird reason, I don't know, maybe this was changed in the meantime. What was it? Command Shift I. So if you track changes in here, for some reason, as you can see, every one of the views updates if you just change one. And this is somehow the React idiomatic way. It gives you this one is pure React, and this one with Redux, which has the same problem. I haven't looked at the code. I don't know what the problem is. And so it actually turns out that on many browsers, in this benchmark I've tried, Coconut rendering through Preact is faster than Preact's idiomatic rendering, because the tracking and the data changes is basically, I spent 2 years on it, so it's not that bad. So and here you can see the different things. So from left to right they are getting slower and slower. Although quite interestingly, React uses the least memory, which is also interesting. Okay, so what's next? There's a lot of stuff, but basically the API is finally getting stable, and it's consistent across all backends, all renderers. For all there's a lot of life cycle callbacks that you can define in your views, so that you can access the underlying physical UI structure and whatnot, and clean up when your component gets thrown away and whatnot. So that's stable now. There's going to be releases soon, I hope. We're probably going to look at choosing this at Docker, because the performance differences probably don't matter for us, but our company is generally moving into a React direction, as many do. And we often get criticism that it's hard to use hacks with other technologies, but actually, okay, there's something to it, but we now have a solution. There's basically very little testing. The test suite is very, very small, I should say. There are a couple of things about auto-completion diagnostics that need to be improved still, especially since things changed a lot with recent hex versions. And time permitting, I'm going to look into more backends that could be added, which is not that much work. Like the Coconut VDOM, for example, is 150 lines of code or something, because you really need to just tell the differ how to create native elements, how to apply properties to native elements, and how to add children to native elements, and then the rest happens. So I'm gonna try that with Hex UI, and then probably with some native stuff, which I think is actually quite interesting, because as a technology we could come forward with a UI solution that, unlike Hex UI, which is great, and React Native, which is also great, does not try to present you the same API everywhere, but it just says, okay, this is a programming model that's actually quite nice, but you can go native. You get everything. You just don't need to relearn programming for every platform that you're going to. Perhaps that's an interesting value proposition, perhaps not. We shall see. But yeah, so that's where this is going, and I think that's actually already the end of my short presentation.
Okay.
Questions? Anyone?
Yes. Do you have something like the React context, or how do you avoid prop drilling? How is it called to push the props from the parent element right down to the
Yeah.
bottom? Is there something?
So no, there's nothing of that kind. Although I think there was a comment made by Dan Abrahamoff, or that React Redux guy. He said that the best way to actually avoid that is, instead of passing down props and then rendering them in some child, what you do is actually you have structural components that define something like a page or a form or a dialogue, and then you pass in the header already with the data inside. So the parent component does not create the child. The parent component accepts the child, so it doesn't have to handle all the data for it.
Yeah, I know what you mean.
And I think this
just
generally.
wonder, how do you combine this with type safety? Because the context stuff in React is exactly for this.
Yeah, but I don't think it's a very good solution. Personally, I don't think the context stuff is a very good solution, because then your components, the higher up they are in the hierarchy, the more they know about the application. They know about the structural layout of the UI. They also know how it's going to be filled. So they pick the content. They have to forward all the data. They have to, like, even if the data would alone flow through the context, they would still have way too much responsibility. It's much easier. You just define the basic structure, like there's a header here, there's a sidebar there, there's blah blah blah. And instead of letting the user trickle down through 3 layers and then creating a user profile view badge thingy, which is then hard coded to be there, what you do is you create your UI and you pass in a user profile badge in the children somehow. And then you don't have to, for one, you can remove the user profile badge at any given moment when it makes sense, and it's no longer hard coded, and you don't have to shovel all this data around as well. But we can discuss that. I will show you that. Yeah. But yeah, I mean, suppose somebody finds a good usage for context, I can add it, but I'm not actually. So far, I'm convinced that most of the time there's a better solution. But we'll have to see.
I'm curious about this React Native thingy.
Yeah.
All the examples I've seen so far are on mobiles, but why is it available for like desktop systems?
Yes. I mean, there's how should I say? There's a unified API for some components. Then there's some platform-specific stuff, but still considered the standard. And I think of the unified API, there's also a web implementation, so you can just put this into any browser. Yeah, and I think Microsoft has actually maintaining one for one of the many Windows forms or whatever it is that they are rendering. I don't even know.
I'm just
Windows Presentation Foundation. One of those things.
Yeah.
They have an implementation.
I'm just thinking that it sounds like a good alternative to all this heavyweight Electron applications. Why is it not popular?
Yeah.
It's not really related to Coconut, but I'm just curious.
No, I mean, it would be a good alternative, definitely. Although, on the other hand, I think, well, I don't really know. When I first used Electron, it was actually really fast. And I think that this got worse over time. Yeah, but it's like, again, if you look at what they are doing, there's a lot of weird jQuery stuff going on and blah, blah, blah. I mean, there's, how shall I say? There's a big copy and paste culture in the web community, and
still okay.
And well, that's what you get. Not sure it would render so much faster if it were native.
So you say that the problem is not the actual HTML render.
Well, it's 2 parts, but I think I'm not sure that fixing one alone will make the problem go away.
So just using coconut is enough to fix the performance issue?
Well, you have to learn hacks, which already kind of, how shall I say, makes a big filter. So yeah,
Something.
okay. Thank you.
You.
Cool.